A very good morning to all of you. I am Mr. Kamlesh Ahirwar, Assistant Professor of IIMT College of Science and Technology, Greater Noida. Today, in this lecture, we will discuss normalization of database. So, we will discuss the one by one topic: first normal form, second normal form, third normal form, and BCNF, and fourth normal form, fifth normal form. We also discuss the concept of normalization, and we will discuss the need of normalization, what is the advantage, disadvantage of normalization. So we will discuss further slides with details. To normalization, what is normalization of database? You know that normalization is a technique of organizing the data in the database. Normalization is a technique. Which type of technique? Organizing the data in the database. Normalization is a systematic approach of decomposing tables to eliminate data redundancy, repetition, and undesirable characteristics like insertion, updation, and deletion anomalies. It is a multi-step process that puts data into tabular form, removing duplicate data from the relations tables. Normalization is the process to eliminate data redundancy. The main concept of normalization is that the reduce the redundancy from the database and enhance data integrity in the table or enhancing the integrity. It is a multi-step process that sets the data into tabular form and removes the duplicate data from the relational data. I again discussed that eliminate the redundancy or eliminate the duplicate data from the database. What is the need? We will further explain in slides. Normalization organizes the columns and tables of a database to ensure the database integrity constraint properly execute their dependencies. How to execute dependencies database? So we will discuss in the database dependency. It is a systematic technique of decomposing tables to eliminate data redundancy or repetition and undesirable data. Okay, in 1970, Edgar F. Cord defined the first normal form. Now let's understand the type of normal form with the help of example, and also we will also discuss the dependencies in use in the normalization. So first of all, before the type of normalization in DBMS, we will learn what is the need of normalization in database. The normalization required for what? Eliminating redundant, useless data. Eliminating the redundant, any useless data, therefore handling data integrity. Because if data is repeated, it is increase the chances of inconsistent data. But we want the consistency in the database. So we we remove the redundant data or duplicate data, so we get the consistent data. Normalization helps in keeping data consistent by storing the data in one table and referencing it everywhere else in the database. Storage optimization, although that is not an issue these days because database storage is cheap, breaking down large table into smaller table with relationship. So it makes the database structure more scalable and adaptable. Ensuring data dependency makes sense, that is, data is logically stored. What is the problem? Problem without normalization. What is the problem in that? If a table is not properly normalized and has data redundancy, any repetition data, then it will not only eat up extra memory space, but will also make the difficulty for you handle and update the data in the database without losing data. Insertion, updation, and deletion anomalies are very frequent if the database is not normalized. To understand these anomalies, let us take an example of the student table. These are the student table. The student table has contained 5 columns. It means 5 attributes. First one is roll number, second one is name, third one is branch, fourth one is HOD, and fifth one is office time. This is the attribute of the table, any column of the table, and this is the record. This table has a four record. In the table above, we have data for four computer science students. As we can see, data for the fields, branch, HOD, head of the department, and telephone, office telephone number are repeated for the student who are in the same branch in the college. This is data redundancy. Look here, HOD, Mr. X, Mr. all data, same name. Office telephone, all name, number is same. So if we want to change this data, particular data, okay, we want to change the HOD name where name is Mr. X. So also changes all four details also will be changed. But we want to change only one detail. So how it is possible? Firstly, we will use the normalization, and we will use normalization. So separation of the data and removing the anomalies from the data. So we will use normalization. Okay. What is insertion anomaly? Three type of anomaly: insertion, updation, and deletion. So firstly, we will learn what is insertion anomaly and database. Suppose for a new admission, until and unless a student option for a branch, data of the student cannot be inserted, or else we will have to set the branch information as null. Also, if we have to insert data for 100 students of the same branch, then the branch information will be repeated for all those 100 students. These scenarios are nothing but insertion anomalies. If you have to repeat the same data in every row of data, it's better to keep the data separately and reference that data in each row. So in the above table, we can keep the branch information separately and just use the branch ID in the student table, where branch ID can be used to get the branch information. And second one is updation anomaly in DBMS. What if Mr. X leaves the college, or Mr. X is no longer the HOD of the computer science department? In that case, all the student record will have to be updated, and if by mistake we miss any record, it will lead to data inconsistency. This is an updation anomaly because you need to update all the records in your table just because one piece of information got changed. In our student table, two different pieces of information are kept together: the student information and the branch information. So, if only a single student is enrolled in a branch and that student leaves the college, or for some reason the entry for the student is deleted, we will lose the branch information too, because this is the due to the deletion anomaly of database. So never in DBMS we should keep two different entities together, which in above example is student and branch. Okay, and different type of normalization we will use in normalization technique: 1NF, 2NF, third NF, BCNF, 4NF, and 5NF. We will also 1NF, 2NF, 3NF, 4NF, but we will discuss 4NF, 5NF also, 4NF, 5NF also in this video. First normal form. A table is referred to as being in its first normal form if atomicity of the table is 1. Here, atomicity states that a single cell cannot hold multiple. What is atomicity? Here, atomicity states that a single cell cannot hold multiple values. It must hold only a single value attribute. The first normal form disallow the multi-value attribute, composite attribute, and their combinations. Now you will understand the first normal form with the help of an example. Below is a student record table that has information about student roll number, student name, student course, and student age. So look here. The roll number 1, name is Rahul, course is C and C++. These are the two records, but the condition of first normal form is that the one column contain only single attribute, single values, or age is single value, but no problem here age, but problem is this course, because these attribute contains two data. but this is not atomic. So we will use the atomic in further tables. In the student record table, you can see that the course column has two values. Thus, it does not follow the first normal form. Now, if you use the first normal form to the above table, you get the below table as result. So we will apply the first normal form. So this table is after the first normal form. This table is shows this type. Rahul C 22. Rahul C plus plus 22. So these are the atomic values 1 and 2. So the break, the first record is break into the two records 1 and 2. Okay. By applying the first normal form, you achieve atomicity, and also every column has unique value. Okay. Before proceeding with the second normal form, get familiar with candidate key and super key. What is candidate key? A candidate key is a set of one or more column. This is the set of, look here, ID roll number, set of one or more column is called the candidate key. Can identify a record uniquely in a table, and you can use each candidate key as primary key. Now let's use an example to understand this better. Super key. Super key is a set of over one key that can identify a record uniquely in the table, and the primary key is a subset of the super key. Here, primary key is a subset of a super key. Okay, let's understand this with the help of example. Okay, second normal form. The first condition for the table to be in second normal form is that the table has to be in a first normal form. The tables should not possess partial dependency. The main concept is this: tables should not possess partial dependency. The partial dependency here means the proper subset of the candidate key should give a non-prime attribute. Okay. What is partial dependency? When a table has a primary key that is made up of two or more columns, then all columns not included in the primary key in that table should depend on the entire primary key and not on a part of it. If any column which is not in the primary key depend on the part of the primary key, then we say we have partial dependency in the table. Now understand the second normal form with the help of example. Here the customer ID is store ID and store location. These are the table. Okay, the location table possesses a composite primary key, customer ID and store ID. The non-key attribute is store location. This is the store location is the non-key attribute or non-key element. The non-key attribute is store location. In this case, store location only depend on the store ID. Store location only depend on the store ID, not depend on the customer ID. Okay, which is part of the primary key. Which is this are the combined primary key. Okay, hence this table does not fulfill the second normal because the store location depend only the store ID, not depend on the customer ID. If the store location depend on the customer ID store ID, then no problem. But this is partially dependent. Partially it means only dependent on the single column. Okay, not dependent on the both the column because both the combination are the primary key. So this is not the proper subset of the second normal. To bring the table to second normal form, you need to split the table into two parts. This will give the flow. Customer ID, store ID. And the store ID is the store. Store location. Store location is dependent on store ID, no problem. But store ID and customer ID, this is the different table. So these are the two tables. Split this table in the two tables. Okay, so these are the second normal. As you have removed the partial functional dependency from the location table, the column store location entirely depends on the primary key of that table store ID. Now that you understand the first and second normal form, you will look at the next part of the normalization in SQL tutorial. Next is the third normal form. The first condition for the table to be in the third normal form is that the table should be in the second normal. Firstly, the table should be in the second normal form. And second point, the second condition is that here should be no transitive dependency for non-prime attribute, which indicates that non-prime attribute which are not a part of the candidate key should not depend on other non-prime attribute in the table. Therefore, a transitive dependency is a functional dependency which A A determines C. A determines C. A determines C indirectly because of A denoted B and B denoted C, where it is not the case of B denoted A. Okay, that B denoted A. The third normal form ensures the reduction of data duplication. It is also used to achieve data integrity. Okay. What is transitive dependency? In table, we have some column that act as the primary key and other column depend on the column on this column. But what if the column that is not the primary key difference on another column? That is also not a primary key or part of it. Then we have transitive dependency in our table. Below is a student table that has a student ID, student name, subject ID, student ID, name, subject ID, subject, address of the student as its column. In the above student table, student ID determines subject ID and subject ID determines subject. Therefore, student ID determines subject by a subject ID. This implies that the table possesses a transitive functional dependency and it does not fulfill the third normal form criteria. Now we change the table into the third normal form. You need to divide the table as shown. Student ID, name, subject ID, address. So we will split the table in two parts. This type of table is subject ID is subject because the subject is dependent on the subject ID. Okay. As you can see in the board table, all the non-key attributes are now fully functional dependent only on the primary key. Here, so this is subject is fully functional on the subject ID. In the first table, column name, subject ID, and address only depend on student ID. In the second table, the subject only depends on subject ID. Here, the address, subject ID, name is dependent on the student ID, and subject and dependent on the subject ID. Okay. Bias code normal form. Next one is bias code normal form, BCNF. Bias code normal form is also known as 3.5 normal form. It is the superior version of third normal form and was developed by Raymond F. Weiss and Edgar Epcot to tackle certain types of anomalies which were not resolved with third normal. Okay, the first condition for the table to be in Weiss code normal form is that the table should be in the third normal form. Secondly, every right-hand side attribute of the functional dependencies should depend on the superkey of the particular table. Okay, for example, you have a functional dependency, x belongs to y, and y is dependent on a x. In the particular functional dependency, x has be the part of the superkey. X is the part of superkey of the provided table. Consider a table subject. Here, the subject, student ID, subject, and professor. The professor depend on the subject. Professor dependent on because which professor is particular subject. Okay, so professor depend on the subject, not dependent on the student ID. Okay. Next one is a fourth normal form. Fourth normal form. A table is said to be in the fourth normal form when it is the Weiss code normal. Firstly, the table should be in the Weiss code normal form and it doesn't have multi-value dependency. What is multi-value dependency? A table is said to have multi-value dependency. The following conditions are true. Which condition true? For a dependency, A belongs to B and B dependent A. If for a single value of A का कोई भी column, single value of A, multiple value of B exists, multiple value of B exists, then the table may have multi-value dependency. Okay. Also, a table should have at least 3 columns for it to have a multi-value dependency. And for a relation, our relation ABC is an attribute. If there is a multi-value dependency between A and B, then B and C should be independent of each other. Okay. Next one is fifth normal form. The fifth normal form is also called the PJNF, Project Joint Normal Form. It is the most advanced level of database normalization. Using fifth normal form, you can fix joint dependency and reduce data redundancy. It will also help in fixing update anomalies and database management system design. And thank you so much for watching this video. Thank you. Thank you so much.